Hey folks, this is Emily with American Resiliency. Thanks for joining us. This is the second half of Ash's teaching on building heat resilience. For those who don't know her yet, Ash is a professional architect with a particular focus on climate resilience. She's also the reason we have our Discord. If you want to nerd out about the built environment with her, she invites you to come chat with her as grade A on the Discord. Part one of her teaching focused on methods for removing unwanted heat from your home. In this second half, she'll teach us methods to keep extreme heat from entering the home in the first place. So, for those of you who pointed out that we didn't talk about canopies or other important barrier type methods against heat, this is the teaching where they're going to be in, I promise you. So, the link to part one is in the video description, as are some resources Ash will be referencing in this second half of her teaching. Let's get going.
As we've mentioned before, the second step is going to be keeping heat where we want it, so outside your house. These methods are often also included with the other passive cooling strategies, but I like to think of them a little bit differently since we're just using them to do one thing, keeping the heat out. So rather than trying to manipulate the temperature, we're just keeping heat out with this one. Here's a little overview of heat transfer, so it's probably a throwback to middle school science for some of you. Convection is the transfer of heat through a liquid or gas caused by a molecular action. Heated fluids are more buoyant and they rise while the cooler fluids sink. Conduction is the transfer of heat from one surface to another by direct contact. So if you grip that hot handle on the pot, it's going to transfer heat from it to you. And then radiation is energy that's radiated in the form of particles or waves. So you've experienced this when you're standing around a fire and your front side gets too warm, so you turn around and let your back feel the heat. That's radiation from the fire that's traveling to the surfaces around it that it can see. So anything that can see the flames is going to get heated up. Conduction. So we're going to talk about conduction first. To prevent conduction to our bodies, in the example we just saw, we would use an oven mitt when we're picking up that pot. Adding a thick heat-resistant material between us and a heat source is going to slow the transfer of the heat. In buildings, we use insulation. The insulation wraps every part of the conditioned space in a continuous plane that's referred to as the thermal boundary. The thermal boundary is shown here in red. And notice that since we're worried about keeping cool, I've actually broken the thermal boundary at the basement floor down here. That's not something that's normally done. And if we were in an environment where we were worried about cold temperatures, I wouldn't do that. I'd wrap the building completely. But in our case, we're worried about heat. And so we want to build a little insulation bubble around our area of contact with that cool thermal mass of the earth. We're using the earth to keep cool.
I wonder if you were in an area where there's extremes projected to continue in both directions, say South Dakota, is there a possibility that you could have a home that had a baseline design like this, but you could break the conduction by putting down some kind of a barrier in the winter over the basement? Like if you had a big insulated rug that you rolled out on the basement floor in the winter to add to that conduction layer.
That would definitely help. And you can also think about changing the behavior patterns of your family between seasons. In the summertime, maybe you want to all sleep in the basement if you can. And in the wintertime, you're moving up to the second story of your house where it's going to be warmer. So I think a lot of these things are going to require us to change our behavior patterns a little bit to keep comfortable if there's no power on.
It's funny how weird that sounds to the modern ear, but that's why houses used to have those giant wraparound porches, is because you would sleep on the porch for the warm season of the year. And that was the normal thing to do for people of all social classes.
Absolutely. Yeah. We've lost so much of that kind of common sense thinking because we've got air conditioners and heaters and we just touch the thermostat button. All right. So R values measure how well insulation or any material resists heat flow. So a higher R value means greater insulation performance. The U value is the reciprocal of the R value. So it's 1 divided by R. It's used to measure the rate of transfer of heat through an assembly. So you're going to commonly see this listed on windows or doors. If you go to buy new windows, it'll tell you the U value. So just remember, we're looking for high R values and low U values. This is a chart that shows the recommended insulation values for different areas of the country. These have been calculated for heating. So traditionally, whenever anybody's looked at how we need to insulate homes, they're focused on heating because that's historically where the greatest energy use has been. But if you look in areas of the South, they are required to have much less insulation than other parts of the country. So these homes are going to be under insulated for extreme heat events. Older homes that wouldn't meet today's code are also going to be under insulated.
I remember the apartments that I lived in Phoenix. They had just no insulation, and you could run the AC constantly. We had a
Mm-hmm.
house that we rented in Fresno when we were living in California. No insulation. When it was over 110, you couldn't get it below 85 in the house. I think we think about insulation for heat, but thinking about insulation for cool could improve our energy efficiency so much today in warm regions of the
Absolutely.
country.
Yep. So luckily, it's possible to add more insulation without completely ripping your house apart. If your walls are poorly insulated, you can use dense pack cellulose installed into your wall cavities through holes drilled into your walls. So there's not any need to tear off all your drywall, luckily, to re-insulate. It's usually done from the exterior, but it can also be done through the drywall. It's not a DIY project, but they just drill holes and use that little hose to shoot the insulation in. And that dense pack insulation can act as both an air barrier and an insulating layer. So it's going to help your walls resist two types of heat transfer, convection and conduction.
And cellulose, you say it's a cellulose pack? So
Yeah,
it's not like you're filling your house with fiberglass or anything
yeah,
necessarily.
and it's not a foam. There's been a big push towards foam recently, which is a great insulating material, but it also makes me really nervous because flammability. And so I like to try to select materials that are a lot more resistant to fire, especially being out here where I am.
I think it's really smart. I've also heard that insulating foam is really shaking up the home insurance market in the UK, where a lot of insurers will not insure houses that have foam insulation.
Yeah, so that is an issue having to do with vapor. And when it gets trapped in the walls, those walls are supposed to be, especially in a lot of the historic homes in the UK, they need to be vapor permeable. A lot of them are cob or stone. And so vapor needs to be able to pass through. But a lot of foams will trap vapor where it is and it condenses in the wall. And then you get mold problems and you get rot problems. So it can be really problematic if it's used incorrectly.
I appreciate the chance to talk about some of the problems with alternatives to this cellulose fill and the way that the cellulose fill addresses those increasingly serious problems.
Yeah, if you're considering doing anything like this, come talk to me on the Discord. I've got big opinions about insulation. I will help you out. Yeah, there's a lot of things that need to be considered so that you make sure that you're not damaging your house. Yeah,
I'm so glad we have you to help with these things.
it's fun. I love to nerd out. So anytime anybody wants advice, come chat. Vented attics is something else that I want to talk about. They can lose a lot of heat in the winter and they also become really hot in the summer. In addition to making sure that you've got good venting in your attic, also make sure that you're well insulated. Use cellulose or fiberglass. You can do fiberglass if you want to. I like cellulose. And it's just a blown in insulation to improve your R value. There's lots of insulation companies who will do this fairly cheaply. They call it blow and go. And it's fast, but I would make sure that you've done other attic projects like air sealing or adding radiant barriers first if you want to do that, because you don't want to be stepping on all your new insulation and packing it down. Another area you can check is your crawl space. So you'll usually see fiberglass bats up in between your floor joists, and that's great. But pay attention to the condition of it. If it looks bad, it's probably not working. Another option is to encapsulate it. I think that I've got a short on your YouTube channel about encapsulation. So that's going to move the insulation from in between the floor joists to the stem wall around the perimeter of your crawl space. This is going to allow any HVAC equipment that's in your crawl space to stay within that conditioned bubble of your house. Rather than working really hard because it's the same temperature as the air outside, it's going to be down inside that air conditioned bubble.
Oh, that would be huge for the efficiency. That's really
It's
cool.
huge for the efficiency. Yeah. And then it also kind of provides another point of contact with that thermal mass of the earth. So again, it's my favorite passive system. I love it.
Well, like I think about philosophically centering on the earth a lot. And I really love that there is this super practical center on the earth, be physically connected to the earth, home design element. You know, it's like not an idea.
Yep. All right. So I wanted to do a fast note on thermal bridging. Wood framing is not nearly as good at insulating as actual insulation. As you can see in this infrared thermal camera photo, the wood studs are letting a lot more heat through the building envelope than cavity insulation that's in between them. And the walls are usually about 20% framing material. So 20% of your wall is letting a lot of energy through. One great option for retrofitting is exterior insulation. And so that's going to wrap the entire exterior of the wall, even the framing, in a continuous layer of rigid board type insulation. And this is another spot where I don't prefer foam. I really like mineral wool. It is both fireproof and vapor permeable, so it's going to work really well for most types of retrofits. Rock wool comfort board is being installed in this example. The wood on the outside is called strapping, so it basically just straps it to the wall and it helps create an air gap for water to escape.
I've heard you talk about mineral wool before as your like chef's kiss for fire resilience if you're going to be doing a big exterior retrofit.
Yeah, I love this for an exterior retrofit, especially if for the strapping you use some sort of a metal. It's a really easy way to wrap your home in something that's non-flammable. So even if flame comes into contact with the outside of it, it's going to be much harder for it to burn.
Cool.
I do just want to say that this is kind of a next level insulation. It's not going to be cost effective for most people probably. So I would start by making sure that you've checked all of the other passive method boxes that you can before worrying about something like this. But if you are in a region where you are kind of making your stand, you know that this is your forever home and you want to make it absolutely as resilient as possible, both for heat and for fire, I would absolutely recommend mineral wool as an exterior wrap on your building.
It's good to know these sorts of solutions are out there. It's good to know that if you want to dream big, that this is the sort of thing you could do.
Yeah. All right, so we're going back to our pot over a campfire. So convection is that hot water swirling around the pot. So the temperature heats up in some areas and the water rises and then it cools down and sinks. Fluids and gases are great at transferring heat and they like to equalize temperature and pressure. So air is always going to flow from high pressure to low pressure and from hot temperature to cold temperature. It's a really good idea to seal up our house as much as we can so that air doesn't accidentally leak in because of those temperature and pressure differences. Any openings that you've got in your house should be planned and operable. Another important reason to air seal is that we can seal off outdoor pollutants when we want to, which around here is a really important factor during fire season. It's important to use the same boundary that we use for our thermal boundary for our insulation for our air sealing boundary. So this one is called the pressure boundary, but it should be the same red line going around your building that you did for the thermal boundary.
I like your emphasis on air quality. I think that even if we're in areas where the fire risk isn't directly so high, the risk of smoke is going to be increasing basically everywhere, basically nationwide.
Absolutely. And even if it's not fire, if you've got allergies or something, being able to lock down your house pretty tightly during certain seasons is going to be valuable to a lot of people.
You know, that's an interesting point as I'm reviewing information for the Pacific Northwest because we do expect substantially larger pollen counts as part of the landscape transformation there.
I'm not happy about that, Emily.
I'm sorry. It's further towards the sea. It shouldn't hit you too bad.
All right, so for that pressure boundary, for the most part, we're assuming that the inner drywall surface along the exterior walls of your home is going to be the pressure boundary. After all, that's usually where the insulation is right behind your drywall. But there's a lot of holes in drywall, as you can see. So this is looking through an infrared thermal camera during a blower door test. You can see how air leaks in through holes in that pressure boundary. Not only is it carrying conditioned air out of the home, it's also letting in that outdoor air pollution that we just discussed during allergy or wildfire season. So it's good to get that pretty locked down if you can. So I mentioned blower door tests. It's easiest to identify these leaks with a blower door test and infrared camera. To anyone wanting to work on air sealing, I would recommend reaching out to your local power company because a lot of times they have blower doors and the technicians to run them and they'll give you a good deal on blower door tests. There's also lots of insulation contractors who offer this service. In some states, you actually have to do a blower door test as part of the home inspection process during a home sale. So you might already have that information available to you. So I'm not going to go too much into air sealing because it can be a little bit of a complex topic because if you air seal too much, you're going to need mechanical makeup air in the form of an ERV or an HRV, which would mean that during a power outage or emergency, you'd have one more appliance to find backup power for. But it's very much a big push for the building industry right now. And And I'm sure if there's any architects or engineers hanging out in this channel, they'll let me know in the comments because there's a lot of people who are really pushing hard for it. I actually have a blower door sitting right over here. So I am also a blower door technician, and I know how important it is to have your home as air sealed as you can without hopefully needing a great deal of makeup air.
That's a real tension between active and passive methods. And
Yeah.
it's interesting to hear that the building industry is moving towards designs that would require active methods instead of considering a move towards natural building materials and passive methods.
You know, everybody likes to have a metric. And so air exchanges per hour in a building is a really easy way to measure one bit of efficiency. And so it's something that's really been pushed on. You know, it's a lot harder to measure something like how shaded is your building. These things can be done in building modeling, but if you're going to write a building code that people have to build to, it's a lot easier to say, oh, you need this many air exchanges per hour. So I think that's one of the reasons that it's become such a big push for the building industry. And so when you talk about passive homes, a lot of them air exchanges per hour only have, I think, 0.5 air exchanges per hour. But there's some older homes that I've been to in Boise that have 8. So the entire volume of the building, when you pressurize it, the air is flowing in and out of that building 8 times per hour. So you can imagine how much heat or how much cool you are losing through that building envelope when all of that air is moving back and forth out of the building.
It really makes me think about the buildings that are being designed and built for the future conditions we're facing and their power needs. You know, what kind of a future are we building? Are we building a future that can be truly sustainable? And how much of it is going to hinge on active power consumption? It's important tensions. It's cool to think about, and it's important to get this insight into how codes and the building industry is shifting.
Mm-hmm. So if people are interested in doing some air sealing, obviously, first I would have you do the blower door test just so that you know where you stand. If you're already at a very tight house, you probably don't want to do more air sealing. But if you know that your house is super leaky, Energy Star has a really great guide that we can link below in the description. So there's a lot of DIY projects that you can take on and hopefully make your house a little bit more tight. So back to our campfire picture, radiation is that heat coming off of the campfire. If you're sitting under the sun on a warm day, it's going to feel much different than sitting in the shade, right? There are even significant temperature differences between the sunny and shady areas of your yard. And this is from the surfaces in your yard absorbing that radiant heat from the sun. But radiation doesn't only come from the sun. Every material with any amount of warmth, like a fire, will radiate its energy to the colder materials around it. So if you've ever sat in front of a window during a cold day and you felt really chilly, even though the indoor air temperature might be, you know, in this picture, it's 70 degrees. So it should feel really comfortable, but you're actually losing your own radiation to the outside through those windows. So radiation kind of affects all bodies that have any amount of energy in them. So radiation can be managed a few different ways. The first is by breaking sight lines. So basically, if the material radiating energy can't see colder surfaces, the radiation won't occur. Just shade things. So overhangs, awnings, deciduous trees, there's lots of different ways to shade a building. It can drastically reduce your cooling needs in the summer. There are some really great tools online for determining how deep your shades or your awnings should be for your latitude, because as you move around on the globe, the solar angles are going to change. And a lot of times you actually do want the sun to penetrate your house during the winter. But when that solar angle is higher, you can actually put a shade that's going to keep it from getting into the building during the summer. But during the winter, it will still be able to get in. So there's some good tools online for determining how deep your shades should be. And we can post those in the description as well, if that's okay.
That would be great.
The second way is by reflecting the energy away. So we know that if you're wearing a light colored shirt during the summer, it's going to feel a lot different than if you're wearing a black shirt. So light colored surfaces are absolutely the easiest way to reflect that energy away. But a lot of times people like dark colored homes, or sometimes your HOA is going to require that you have a dark roof on your house and you don't have a choice about it. So there's things called radiant barriers, which is this foil looking material. And you can place that behind your roofing or your siding to help reflect that radiant energy away from the inside of your home. And if you're retrofitting, a radiant barrier can also just be placed in your attic behind your roof sheathing, so you don't have to tear off your shingles. You can actually go into your attic and slap it underneath the plywood, and that will keep the heat out. Radiation is probably the best strategy to keep heat where you want it to get lots of gains for very little effort. It can be as simple as just tacking some light colored sheets over your south and west facing windows during a heat wave.
I think it's important to think about that, you don't have to think about it as the perfect solution where you're doing a $10,000 renovation. You can think about, do I have light colored fabric that I could use to improve that cool room, that north facing room of my house in an emergency where you can take action yourself?
Absolutely. Preparing for extreme heat during power outages is essential for safeguarding your health and well being. Being prepared not only helps you stay comfortable during a power outage, but it also ensures your safety in the face of rising temperatures and challenging conditions. So stay proactive, plan ahead, and take the necessary precautions to stay cool and healthy when extreme heat strikes. So I wanted to invite everyone again to join us on the Discord because I'm really happy to deep dive into any of these topics or any other building stuff that they might have questions on.
Ash, thank you so much. That is such a gift to the community. And I really appreciate how this presentation lets us not only think about practical, actionable ways to make a space for our families that would be safe without big retrofits, but it lets you kind of dream big in a lot of different directions with the retrofits. A lot of us, we feel so paralyzed when we look at the future that is coming, but I think this helps us see many practical ways to respond that will impact your quality of life in heat in the future. Thanks so much for joining us, for your offer to continue the conversation, and for this rich teaching. Thank you so much, Ash.
Thank you so much, Emily. It's always a lot of fun. I appreciate it.
Folks, thanks for spending some time learning with me. American Resiliency is a donor-supported nonprofit. We're focused on helping everyone access climate information so we can respond to the changes that are coming. I'd like to take a moment to say thank you to the AR community, to our donors, our volunteers, to everyone spreading the word, and to everyone doing the work on the ground. If you'd like to donate, you can find the button for that at the top right corner of our webpage, www.americanresiliency.org. Thanks for getting ready with me, and talk with you again soon.